Now, who remembers what we did yesterday? Gavin, go. What was it called?
Instantaneous rate of change.
Instantaneous rate of change.
IROC.
A-rock, I-rock.
That's not what
Okay,
we learned.
A-rock and I-rock, average rate of change and instantaneous rate of change, okay? I told you that they were the foundation for derivatives, and today we are actually going to start into derivatives. So, I-rock, instantaneous rate of change, leads to what is called a derivative. And I'm going to define the word derivative for you. The derivative is the formula for the slope of a tangent line to a curve. It is the formula for the slope of a tangent line to a curve. Now, IROC, the instantaneous rate of change formula, usually deals with problems that are talking about velocities more of it than a rate of change. You know, usually they're talking about here is where something is, what is its velocity. Derivatives, on the other hand, are good for any function, okay? So, there are more than one definition, mathematical definitions of derivative. I'm going to introduce two of them to you today. We're going to focus on the easier one of the two. But I'm going to go ahead and show you what they call the formal definition of derivative first. And this is the harder one. But you know what? You've already seen this before, just in a different look. Formal definition of derivative. Okay, as soon as I write it down, you're going to go, that looks vaguely familiar. Here it is. It is the limit as h approaches 0, f of x plus h minus f of x all over h. Okay.
Looks like what we wrote yesterday.
Looks like what we wrote yesterday. What's the only difference? L to x has turned into h. Now, I think the h is cleaner because x and delta x can get kind of confusing, especially when you put them side by side. Is the h and the delta x the same thing? The answer is yes, they are. H represents the distance between the 2 points, and it's getting smaller and smaller. It is just more of the definition of what a derivative is, okay? So, this right here is used for all x's. In other words, if I need to be able to find the formula that will find the slope for all x's on a curve, you use this one, okay? But it is, like the IROC formula was yesterday, kind of ugly. I told you we were going to focus on the easier formula today, and that's the one I want to show you now. It is called the alternate definition of a derivative. Alternate definition of derivative. Okay? Now you may be thinking, well, why in the world would you do a harder formula if you had an easier formula to work with?
Because sometimes it doesn't work.
Pretty much you're right. Sometimes it doesn't work, and the point is the easier one only works to find a derivative at one point. It doesn't find the derivative equation for every single point. So if you had a problem where you needed to find the slope at 2, 3, 5, 9, and 12, you want to use this one because it takes less work. This one, you would have to do this problem 5 times in order to get the slope at 2, the slope at 3, the slope at 5, the slope at 9, and the slope at 12. So, would you rather do 5 individual problems or 1 problem? I'd rather do 1. But if you only need the slope at 2, this one's faster, okay? This one is used to find the slope at a single point. Huh? Exactly. Okay. And here is the formula. It is also a limit, but this time x is approaching a. Now a represents the point that we're talking about. And the formula says f of x minus f of a over x minus a. F of x minus f of a over x minus a. And that's the formula we're going to be focusing on today because I don't have double letters in it. because this a is really a number. Immediately when you do the problem, the a's turn into numbers and all you have left are x's. And those are much easier to do than problems with h's and x's in them. Are you clear on that? Okay? Now, before we go onto the worksheet, I want to talk a little bit about the notations for derivative. Okay? Calculus is like any other foreign language. There are symbols and letters and ways to say things that you need to learn so that you can understand what the question is asking you to do. Okay? So, over here I'm going to write the word function and a line and then derivative and a line. Okay? Now, does anybody in here happen to know who discovered calculus? No, I didn't discover calculus. Okay, Newton was one of them. Newton discovered calculus. Okay? Okay, let me tell you the story behind all of this, okay? Now, Newton started discovering calculus in the 1600s, about the time the Pilgrims were landing on Plymouth Rock. That's how old calculus is, okay? Newton is from what country?
England.
He is from England, okay?
Because he's a sir.
And that's exactly right. He is a Sir Isaac Newton. Okay, there was another gentleman about the same time who was discovering calculus, and he was from, does anybody know?
Ireland.
Germany. Okay. Now, and here is his name. Leibniz. And it is Leibniz. It's not Leibniz. It looks like the word lie. No, it's Leibniz. It's Leibniz. Okay? Okay, a little bit of a grammar lesson I like to give people that I learned a lot when I'm coming down here. Okay? There is a street running right behind the back exit of Reagan. And it is spelled Huebner. And it's pronounced Huebner. Well, what do you think most people who mispronounce it say? Huebner. Because in English we say, well, not the second. That town up I-10 that's spelled B-O-E-R-N-E. That's Bernie. And most people pronounce, the first time I saw it, I thought it was Borny or something. But it's Bernie because it's German. In German, when you have two vowels together, you say the second one, not the first one. It's Leibniz, not Leibniz. Okay. Now, let me tell you a little bit about Leibniz and Newton. Okay? Newton was a little more of a conservative guy. He didn't have a big head on his shoulders. So he's working in England and he's discovering calculus to figure out the orbits of planets. And he knows that he hasn't got all the bugs worked out of the stuff. So he doesn't go public with it yet. He's still working on it. Well, Leibniz over in Germany, he's going, I found out this cool new math and it's called calculus. Yay! And he publishes this big paper and puts it out there and it's riddled with mistakes.
It's in German, so they can't read it.
Oh no, they can read it. They can read it. Okay, so it's riddled with mistakes. So what happens is Newton goes, okay, I'm going to have to go public now because he totally screwed it up. So Newton went public at the same time. So since they were both working independently, they are both credited with discovering calculus. Okay? Why do I say all this? Because as they each developed their mathematics, they came up with their own way of writing derivatives down. And so since two people were writing derivatives down in two different ways, we basically use both of their ways when we're writing derivatives in math. So that's why there's multiple ways to do this. So please write this down. F of x is a function. When I'm wanting to write down its derivative function, I write f with what looks like an apostrophe and then the parentheses x. And you read this f prime of x. F prime of x. That's how you say it.
Do you think there's still math you haven't discovered yet? Yeah?
I do. I do.
I'm working on it.
Okay. I do believe there's math we still haven't discovered yet. I mean, quantum physics, it still hasn't been totally ironed out. Okay. Now, so f prime of x. If I asked you to read that to me, you need to be able to say f prime of x. Okay. If function is called y equals something instead of f of x equals something, y apostrophe or red y prime. That's how you say it. Now, I don't know whose method is whose. I have a feeling this is Newton's way of writing it down. So, The other way is this way. If the function is y, the derivative is written dy over dx. But when you say it, you don't say over, you just say dy dx. All of these, you just say dy dx. You don't say dy over dx. Save yourself a word. Okay, now, why d? Let me tell you why it's d. It's not d for derivative. Okay, what is the Greek letter d? Delta. So change those d's to delta. What do you see? Change in y over change in x, which is slope, which is derivative. That makes sense. Okay? Yes. So, the other method for f of x, I'm writing it last because it's kind of obscure. You don't see it very often. It is d over dx parentheses f of x like so. And it's most often written in theorems, not in homework. So you read this as d dx of f of x. That's how you say it, d dx of f of x. Okay? All right. Any questions on the notation? I had to introduce this to you because we're going to see it on the worksheet we're about to do. And the quiz. All right. If everybody's done writing this down, put that aside, take the exploration, and either flip it over or put it in front of you. The last time we did an exploration, I let you loose and you basically did it by yourself. But there's some pre-cal in here that's kind of obscure, so I want to do most of it together. All right? So here we go. This is called exact value of a derivative, with what we're doing, the alternate form. The figure shows the graph of this function right here. In this exercise, you will use the definition of derivative, basically the alternate form, to find the exact value of, raise your hand if you can say this. Oh, is everybody who says it anyway? F prime of 4. Okay, now, raise your hand if you know what it means, Eugene. What do you think? Just kidding. Okay. Now, what does it mean? Not f prime of 4 is not what it means. What does it mean? Zach, go for it. The derivative of f of 4. You are very close. Give it a shot, Josh. It is the derivative at x equals 4. Yeah, you take derivatives of x values, not y values. So, the derivative at 4 or the slope at 4. Okay? So, by the end of class, you need to know that this means the slope at 4. All right? So, number 1, find f of 4. What does that mean you're supposed to do? The y value at 4. How do you find the y value at 4? Plug it in. So let's do that. F of 4 equals 4 to the third minus 4 times 4 squared minus 9 times 4 plus 46. Okay. This is not as hard as it looks. You can do this without a calculator rather easily. Look at these first two
They
terms.
equal same thing.
They are the same thing. This is 4 to the third and that's 4 to the third, right? So they cross each other out. So negative 36 plus 46 is what? F of 4 is 10. Now look at the graph. Does it look like F of 4 is 10? No. Looks like F of 4. Yes, actually it does, because the scale is tens on the y. You got to be careful there. Notice that's 60.
Good heads up, but
Yep. Okay. Number 2, write the definition of derivative as it applies to f at x equals 4. So, which of the two formulas that we wrote down do you use? The second one, because it's at a single point. So, as you write it down, I want you to change the a's to 4's. Okay? So write this down, changing the a's to 4's. So it will be limit as x approaches 4 of f of x minus f of 4 over x minus 4. Okay. Now, I am going to add something to the front of this. This is calculating the slope at 4. So how did I show you up here to write the slope at 4? What does this also equal? F prime of 4. So this formula calculates the slope at 4. Okay? You all follow what I did? Now the reason I didn't do it here, because I didn't tell you about f prime until afterwards. Okay? So, Number 3 now says substitute the values of f of x, which is up here, and f of 4, which is right here, into the definition from problem 2. So put the f of x function here, put f of 4's value here, then simplify the resulting rational expression and take the limit. Okay, so that means we're going to write limit x approaches 4. Fraction bar. Write down f of x right here. It's off my screen, but you can see it on your paper. X cubed minus 4x squared minus 9x plus 46. I'm going to put that into parentheses for safekeeping. Minus, what did we get for f of 4 again? 10 over x minus 4. Now, that doesn't look like too bad of a limit to do. Okay, what can I do to clean it up first thing? Can I combine the 46 and the 10? Yeah, I really don't need those parentheses, so let's do that. Limit x approaches 4, x cubed minus 4x squared minus 9x plus 36 over x minus 4. All right. What is the first method for a limit that we're supposed to try before we do anything else? Plug it in, direct substitution. Now, I'm a little concerned because if I plug a 4 in the bottom, I'm going to get a 0. This may be a 0 over 0, I'm not sure yet. So I'm just going to take my calculator and test it. So we have 4 to the third minus 4 times 4 squared minus 9 times 4 plus 36. Yep, it's 0. Okay.
Keep going.
Keep going. So equals 0 over 0, which means keep going. Okay? Now, we got a problem though. This is a keep going problem we haven't done yet. Okay? We did a cubic. Okay, we factored, but we've only factored squares. The only cubic we've ever factored is a sophist problem, and this is not a sophist problem. Okay? So this is where I said we got an obscure thing going back to pre-cal. Okay? To divide this by this, there are 2 methods. I'm hearing some groaning already. Long division or synthetic division. How many of you remember the word synthetic division? Not necessarily what it means. Right. Keep your hand up if you remember how to do it. Oh, a couple people. Good for you. Okay. Let's do a refresher course for everybody else. Okay? Draw that right there. This is the shelf. Oh, now it's coming back. Okay. The opposite of this number here goes right there. And then the coefficients from the top go out to the side. So it's 1x cubed, negative 4x squared, negative 9x, and 36. Now is it starting to look familiar? Yeah. Okay, had a feeling. Skip a line, draw a line. Believe me, this is much better than long division. Synthetic division, yes. Okay, the first number always comes straight down. What did we do with these 2 numbers? Multiply, good. And then what do we do with those 2? Add them together. Get 0. Do it again. 4 times 0, 0. Add them together, negative 9.
Negative 36. And now we have no remainder.
Okay, and that is the remainder. Very good. Who said the remainder? Good job, Trent. Remembering that's the remainder. Good job. Okay, so now, what is this? What does that answer really mean? X squared. Okay, why is it x squared?
Because you're going to take the x third out.
You go down a power. This was x cubed to start with. You divided, so it goes down a power. So this is telling me now that this top divided by that bottom leaves me with x squared minus 9. X squared plus no x's minus 9. The last term is always discarded because it is the remainder. Okay, now can you plug 4 in there safely?
Yes.
And you get what? No, positive 7. Okay, so now write f prime of 4 equals 7, and you are done. Caitlin, did you have a question?
Yeah, I'm not really sure on the denominator, where does the x go? You have the 4, but where does the x go?
Okay, all of the x's from this whole top and bottom disappeared. The synthetic division allows us to do it with just the coefficients.
Oh, then why is it positive?
Okay. Oh, why is there not a 1 there? It just doesn't work that way. I'd have to show you paralleling it with long division where it goes. So if you want me to, I can sit down and show you. But just to suffice it to say that you don't need it. Yes. I'm sorry, I did not hear you. The opposite of what's on the bottom. If it was +3, you put -3. You can't do it. You can't do synthetic division. I won't give you any like that. You would have to do long division with that one. Okay? All right. Shh. Now, I'm just going to call on somebody. Okay. Shh. I would like Kelly to read this to me. Don't tell me what it means, just read it to me. What I'm pointing at right here. How do you say it?
Wait, f prime of 4 equals 7.
Very good. F prime of 4 equals 7. Now, shh, okay, Cash. What does it mean? Okay, hold on. I'm talking to Cash.
Prime of x equals 4.
Not exactly.
No, okay.
Okay.
I don't know.
Okay, if you don't know, Emily, give it a shot. Okay, shh. Let me repeat what she said. She said the derivative at x equals 4 is correct. Okay? Now, what is another word I can substitute for derivative? Slope. Because slope, derivative is a brand new word. Let's take a word we know. The slope at x equals 4 is 7. That's what this means. So you may want to write that down. The slope at x equals 4 is 7. That's what we just figured out. Makes more mental sense to you, probably. Okay? All right. Scoot up to the top of the next column. Can I move?
Yes.
Okay. Number 4 says plot a line on the graph at 4, f of 4. Now notice they've already given you a dot there. That has the slope of what you just got, which we said was 7. Observe the different scales on the two axes. Okay. Up one line on the y is 10. So I need to plot a slope of 7. So I better go about 2/3 to 3/4 of the way up. Each of these is 1. So instead of going up 10 and over 1, I'm going to go up 7 and over 1 and be about right there. Do you see that? You see how I got that? Do I need to say that one more time?
Yes, please.
Okay. If I went up one whole line, that's 10. Do you see? Because these are by 10s. I want a slope of 7, because 7 was what I got for the answer below. So I can't go up 10, so I'm going to go up a little less than 10, which is 7, and over 1, because it says my slope is 7. Now do the same thing in the other direction. Go down almost to 10 and over 1. Connect the 3 dots. Is it a coincidence that it looks like that, or was it supposed to? Yes. Tell how the line confirms the derivative is correct. It is tangent to the curve. Tangent to the curve at x equals 4. All right. Bless you. Okay. Number 5. Find the exact value of f prime of 2 using the same procedure you used for f prime of 4. In other words, find f of 2, rewrite this problem where all the 4s are 2s now, and do the math. I want you to work with your table and do that right now. So you're going to redo this problem, but instead of f prime of 4, you're going to do f prime of 2. Okay? See if you can do it with your table.
How do we say the answer to number 3 again? The question you asked me that I got wrong?
Okay, I wrote it at the bottom. Right down here. It says the slope at x equals 4 is 7.
Derivative at x equals
Yes, slope or derivative.
Oh, you did the limits already?
Okay. We are running out of time, I'm sorry to say. And I'm going to wrap up before the bell rings. Let me put the answer up here so you can see it. Okay? Right here. It should come out to be negative 13. If you didn't finish, you may want to just make a note of that out to the side so you can write it down. This will be on the video because I just put it up here so you guys can see it. If you didn't get it done, you can go watch the end of the video and see it. Okay, your assignment is just like this, 4 problems. Now, they're not all going to be synthetic division. Some of them are going to just be conjugates. Some will be smiles. Some will be just factor. Okay, to work them out. Yes, ma'am?
Will it ever not end in 0 the last?
No, it will always end in 0. It will always end in 0.